Now, here we want to use substitution to find the intersection of the lines given by the following equations. So, substitution is typically used if I have at least one equation solved for a variable. And here I do. If it isn't, if you don't have that, you can always solve one of the equations for that variable, and you could just use it like that. That's fine. But oftentimes when you're doing that, as you've seen, when you often are solving an equation for y, you end up with fractions, and you have to kind of be aware of your fraction rules. And sometimes that freaks some students out. So I'm going to use this to, basically replace y in this function here. So I know y is the same thing as 2/3 x minus 4, so I come to that second equation. I'm going to say, okay, x plus 3 times 2/3 x minus 4 plus 3 equals 0. So I'm essentially replacing y with what it equals, and what it's doing is I now have an equation that only has x in it. So I can figure out what x is based off of this. If I distribute that 3, I'm going to have x plus 2x minus 12 plus 3 equaling 0. If I simplify and combine like terms, x plus 2x is 3x. Negative 12 plus 3 is a negative 9. I would add 9 to both sides and divide both sides by 3 to get that x equals 3. I'm not done yet. Remember, I'm looking for an intersection, so I do need an ordered pair. A lot of students get into this habit, especially ones that struggle in math, and I got an answer. It seems to make sense. Yay! And, I got x equaling a number. Well, you're not looking just for x. You're looking for y too. And now what I can do is go to take this y equation again and now replace the x with 3. So y equals 2/3 times 3 minus 4, which is y equals 2 minus 4, y would equal a negative 2. So the intersection is at 3, comma, negative 2.